Welcome to the Register course of the HT8 MCU Basic Tutorial. This course will take you through the register of the HT8 MCU from the following two aspects: Register Introduction and Special Function Register Description. Register Introduction. What is a register? Register is a high-speed memory with limited storage capacity. It is used for storing and processing data, status checking, function configuration, etc. The register width of the HT8 MCU series is 8 bits. Registers are divided into two types. The first type is general-purpose registers, used for storing data. The second type is special function registers, used for special purposes such as function configuration and status checking. The following will describe a variety of special function registers, which include the indirect addressing and memory pointer registers, accumulator, ACC, the program counter low byte register, the lookup table registers, the status register, and other special function registers. It should be noted that special function registers should not be used as general-purpose registers. Special function register description. The function of the indirect address register is to perform corresponding read or write operations on the specified memory address. The indirect address registers include IR0, IR1, and IR2. The function of the memory pointer register is to point to the memory address. The memory pointers include MP0, MP1L, MP1H, MP2L, and MP2H. Acting as a pair, IR0 and MP0 can together access data only from sector 0. While the IR1 register together with the MP1L, MP1H register pair and IR2 register together with the MP2L, MP2H register pair can access data from any data memory sector. The MP0 register is used to point to the desired address in the sector 0. The MP1H and MP2H registers are used to point to the desired sector. The MP1L and MP2L registers point to the desired address in a specific sector. The indirect addressing registers, IR0, IR1, and IR2, although having their locations in normal RAM register space, do not actually physically exist as normal registers. As the indirect addressing registers are not physically implemented, reading the indirect addressing registers will return a result of hex 00, and writing to the registers will result in no operation. Indirect addressing allows the use of an indirect addressing pointer for data operations, replacing the direct memory addressing method that defines actual memory addresses. The accumulator is central to the operation of any microcontroller and is closely related with operations carried out by the ALU. The accumulator is the place where all intermediate results from the ALU are stored. Without the accumulator, it would be necessary to write the result of each calculation or logical operation such as addition, subtraction, shift, etc., to the data memory and then read it out, resulting in higher programming and timing overheads. The temporary storage function of the accumulator can also be used to transfer data between two registers. It is necessary to do this by passing the data through the accumulator, as no direct transfer between two registers is permitted. Let's look at an example of an addition operation. First, move the value hex 02 into the ACC. Then, add the value hex 05 to the accumulator and store the result in ACC. What are the roles of PCL? It provides additional program control functions. Loading a value directly into this PCL register will cause a jump to the specified program memory location. The PCL can also be used as a general-purpose register for computation. PCL considerations. As the register is only 8-bit wide, only jumps within the current program memory page are permitted. When such operations are used, note that a dummy cycle will be inserted. In the MCU structure, there are usually three types of lookup table registers: the TBLP register, the TBHP register, and the TBLH register, all of which have an 8-bit width. TBLP and TBHP are the table pointers and indicate the location where the table data is located. TBLH is the location where the high-order byte of the table data is stored after a table read data instruction has been executed. Note that the lower-order table data byte is transferred to a user-defined location. If the high byte data is required, the data should read from the TBLH register in time to avoid it being overwritten by the next table lookup instruction. This status register contains arithmetic, logical operation, and system management flags, which are used to record the device operating status. The device operating status can be obtained through the status register. Besides the registers previously described, the HT8 MCU also has many other special function registers, such as the SCC register for configuring the system clock source and prescaler, the WDTC register for configuring the watchdog timer functionality. Refer to the appropriate course for detailed usage. Course summary. In this course, we have learned about a variety of registers. You will have a clear understanding of the register. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.